Today we're talking about the renal system, and our experiment will be specifically about the effect of arterial radius on glomerular filtration. The pre-lab quiz and the post-lab quiz will be done by Hind Al-Kos and Noor Al-Shahi. The experiment will be done by me, Mira Kashwani, Robin, and Tiba.
As we can see here, the glomerulus is a cluster of capillaries around the end of a kidney tubule. The afferent arteriole is the arteriole that brings blood to the glomerulus, and it is larger in diameter than the efferent arteriole. The efferent arteriole is the arteriole that carries blood away from the glomerulus. It is smaller in diameter than the afferent arteriole. So why is the afferent arteriole larger in diameter than the efferent arteriole? Well, this is to provide for the increased blood pressure in the glomerulus for ultrafiltration to take place. When the afferent arteriole is larger, more blood can flow into the efferent arteriole, which is of a smaller diameter, and this results in increased blood pressure in the glomerulus. And so, this high hydrostatic pressure forces small molecules, such as water, urea, uric acid, amino acids, and mineral salts, through the glomerulus to the Bowman's capsule and into the nephron, resulting in ultrafiltration.
In this glomerular filtration, we will be changing the values of the afferent radius, the efferent radius, and the pressure.
First, we change the afferent radius and then the efferent radius. And as you can see, the tube size has changed. Next, we change the pressure, and now we're gonna start the experiment.
As blood flows from the source beaker through the renal corpus, filtrate moves through the renal tubule, then into the collecting duct, and then into the urinary bladder. Glomerular capillary pressure display shows the hydrostatic blood pressure in the glomerular capillaries that promotes filtration, and the filtration rate display shows the flow rate of the fluid moving from the lumen of the glomerular capillaries into the lumen of the Bowman's capsule.
After decreasing the afferent radius, we can see the change in the glomerular pressure, glomerular filtration rate, and urine volume. We can also notice that all of them decreased. Now we refill the beaker, and we're gonna start with our next step.
You will now observe the effect of the incremental decrease in the radius of the afferent arteriole.
We're gonna decrease the radius of the afferent arteriole by 0.05. Now we're gonna start our experiment. For our next step, we're gonna keep on repeating the experiment until the afferent radius reaches to 0.35. Now we have a prediction question. What will happen to the glomerular capillary pressure and filtration rate if you increase the radius of the afferent arteriole? So in our previous steps, we decreased the afferent radius, and we noticed that the pressure decreased and also the filtration decreased. So by increasing the afferent radius, we predict that the pressure and the filtration rate will also increase.
So we changed the afferent radius value to 0.55, and now we're going to observe the changes.
Now we increased the afferent radius by 0.05. The glomerular pressure increased and the glomerular filtration rate also increased. The urine volume also increased.
We observed that an increase in the radius of the afferent tubule leads to an increase in the urine volume. We also deduced that since caffeine had a diuretic effect, increases urine formation, it therefore also increases the radius of the afferent tubule. In here, we predicted that when the radius of the afferent arteriole was decreased, then the pressure and filtration rate would both increase. And now we're going to decrease the radius of the afferent arteriole to 0.50 and observe the changes.
By comparing our previous data, which was 0.6 for the afferent radius and then 0.5 in the second experiment, we can see that the glomerular pressure decreased, same as for the filtration rate and urine volume.